So we're at the point now where we need to actually generate our JSON Web Token. And I should let you know right now that I often call these JavaScript Web Tokens, even though that's not the proper name. And that happens a lot in this part of the world for some reason. I'm not sure why, but the proper name is JSON Web Tokens. And right now I'm looking at the Wikipedia page for JSON Web Tokens, and there's a link to this in the course resources for this lecture. And as you can see, the token is composed of three parts. A header, which says what kind of algorithm is used to generate the signature. The payload, which contains a set of claims. And we'll be making claims here momentarily, so don't worry about that. And finally, we have this signature, and that's what securely validates the token. So in effect, you're getting one JSON file consisting of one entry that has these three parts. So let's get started doing this. So I'm going to switch over to my IDE. And the first thing I'm going to do is install a third-party library that actually gives us access to the necessary functionality to implement JWT. So I'll open my terminal window, and I will type go get, and I'll just paste this in here, otherwise I'll make a mistake. But it's github.com/PASCALDEKLOE/JWT. So let's go get that. And that will install the necessary library and add it to our Go mod file. Now, the next thing I'll do is set up a route that points to a handler that doesn't exist yet, but we'll add that in just a moment. So right here, after my /status, I'll add router handler func, and the method will be http.methodPost, and we'll go to /v1/signin, and that will be handled by a handler we have to create in just a moment. We'll call it sign in, like that. Okay, now that doesn't exist yet, so let's go over to our command API folder, and I'll put this in its own file, and I'll call the file tokens.go. Okay, so let's give it a package declaration, package main, and let's start writing things. Now, when you're actually doing this in production, you will almost certainly authenticate users against a table in your database, like a users table, and that would have all kinds of information. An ID, their first name, their last name, their email address, their password, maybe their physical address, whatever it may be. And just to keep things simple and straightforward, I'm not going to go through that entire creation of the users table. Instead, we'll just mock it. And we'll do it like this. I'll create a variable, which I'll call valid user. And this will stand for, or take the place of, retrieving a user from the database. And it will be of type models.user. Now, we don't have a user model yet, so let me just close this and go over to my models. And we'll just add one at the bottom. So we'll call this type user, and it will be a struct. And we'll just give this a few fields. So ID, which will just be an int. Email, which is what they'll use to log in, and that will be a string. Password, and it's not their actual password, it will be a password hash. You never store passwords in a database, but we'll get to that shortly. Okay, so let's format this and give it a comment. User is the type for users, and I better spell the right. Okay, let's go back to tokens. And we have, let's just have this import. That's better. Okay. And we'll just define a user, a dummy user. So I'll give this person an ID of, say, 10. And we'll give them an email of me@here.com. And then we need a password. And the password can't be something like password. It needs to be a hash. So how are we going to do that? Well, it's actually pretty straightforward. What I'm going to do is go to my web browser and open a terminal or new tab, and I'll go to this address. And this address exists on the course resources for this page. And it's play.golang.org. And it's a very, very simple program that takes a password. And as you can see here on line 9, the password I've chosen is the singularly insecure one of password. And it generates a hash for it. So all we do is run this program. And we copy the hash right here. So I'll copy that. And I'll go back to my IDE and paste that hash right in there. Okay, so we format this. So now I have a valid user. I'm going to create another type here, and this is what we're going to use to test whether or not someone's allowed to log into the system. And we'll call it credentials, and it's a struct. And it just has two fields, username, which is a string, and in JSON, I'm going to call this email, because that's what we're receiving when people use our login form. And then we have password, which is also a string, and in JSON, that will be called password. Okay, so we have a valid user, and we have a type. Now let's create our handler, func app, and it takes the receiver of app, which is a pointer to application. And we're calling this sign in, which is what we called it in the roots. And because it's a handler, it takes a response writer, and it takes a pointer to a request. Okay, now we'll declare a variable, var creds, of type credentials, the type we just made, and we'll get the JSON body that's been posted to us and decode that into credentials. So we'll check for an error. Error is assigned the value of JSON from the standard library, and we're looking for a new decoder, and we're going to decode the request body, and we're going to decode it into creds. And we check for an error. If error is not equal to nil, then we'll just say app.errorJSON, and we'll hand it the response writer and create a new error. Errors.new, and I'll just put unauthorized. And of course we return, because we don't want to go any further at that point. They didn't even give us a valid post to log in. Now next, this is the point where you would actually get the username and password, the email and the password in our case, and you would query the database and check to see if there's a valid user that matches that username, and check the password hash stored in the database, against what was supplied. So we're going to fake that by using our hashed, we'll declare a variable called hashed password, and we'll just get that from our valid user dot password. Okay, so that would be a database query in a live application. Next, we want to see if the hash for the password they just gave us matches the hash in the database. In other words, those two hashes could have come from the same password. They might not be the same. They might be entirely different strings. They almost certainly are, but they both should be producible from the password that the user supplied. So we do that by, again, checking for an error and calling bcrypt, which is part of the standard library, and we're going to call compare hash and password. And it takes two arguments, both of which are a slice of bytes. The first one will be a slice of bytes for hashed password, there. And the second one is a slice of bytes from creds.password. What did they supply? And we check for an error. And again, I'll just copy this and paste it here. So if they've got past this point, we have a valid user and we have a valid password. So now we can create our JWT and send it back. So we're going to create a variable, and now we're going to start using that package we just imported. And now we're going to start using that JWT package we just imported. So we'll declare a variable called claims, and we're going to make the claims part of our JWT. And it's of type jwt.claims. And now we just start filling out the various claims we want to be included in our token. So claims.subject is the first one, and that's going to be equal to whatever we want to store in this. And in this case, all I'm going to store is the user ID. And it needs to go in the form of a string. So I'll just say format.sprint, and we want valid user.id. And that will turn it into the correct format. The second thing we want is when was this issued? Claims.issued. And that will be equal to now, the current date and time, but it needs to be in numeric format. And fortunately, this package, JWT, gives us a new numeric time, and we can just apply the argument of time.now. And the next argument, or the next thing we need in our claims, is claims.notBefore. This token is not valid before, again, now. JWT.newNumericTime, time.now. And now we want, when does it expire? Well, we're going to make this expire in 24 hours. That should give us sufficient time to get things working. jwt.newNumericTime, and it's time.now.add, and we'll add 24 hours. So 24 times time.hour. And who issued this, and who's allowed to look at it? Claims.issuer, and this is just the domain name. And we'll use anything. As long as the token we issue, the audience, includes the issuer's domain, then we're fine. So we'll just use mydomain.com. And who can see this is claims.audiences, plural, because you might be able to access this REST backend from multiple remote sites. So it has to be a slice of strings. And we'll just put one entry in there, mydomain.com. So we've made our claims, and now it's time to actually create the token. So we're going to create a variable, which I'll call JWT bytes, because we're getting a slice of bytes. We'll check for an error, and that is assigned the value of claims.hmaxSign. And this actually creates and signs our token. And we need to know what algorithm to use. And we're going to use jwt.hs256, which is just a constant in that package. And we're going to pass it a slice of bytes. And what we need to pass it is actually our secret. And we don't have a secret yet, but we'll make one in a moment. But what I'll do is just finish writing this particular function call, and then we'll go get our secret and put it in our app config. And we'll put it in app.config. And we'll create a new field called JWT, and that will have a field called secret. Okay? So before we can go any further, we have to go make that secret. So first of all, let's add the necessary fields to our config. So back in main.go, we'll find our config, and we'll add JWT, which will be a struct, and it will have one field called secret, which is a string. Okay? So we've added that. Now let's go create that secret. And again, I have a link on the course resources page to this address. Again, on play.golang.org. And this is a really, really simple program. And as you can see on line 11, I have a singularly insecure secret. It should be a much longer secret, but this is what's used to generate the secret we're going to put in our program. So just leave it like this and run it. And copy this secret right here, the part after result, and make sure you don't get any leading or trailing spaces. Copy that and go back to main.go. And what we want to do is assume, for now, that this is going to be read as a command line argument, a flag. So we'll just say flag.stringvar. And we're going to read it into our config variable, jwt.secret. And it's going to be called jwt-secret on the command line. And we'll give it a default value. And this, of course, will not survive into the final version of our program, but this is just for development purposes. This is our default secret. And then we'll have a little bit of descriptive text at the end. And I'll just put secret there for now. Okay? So that gets us our secret. And again, this is not how you would do this in production, and we'll certainly fix this before this course is over. Ideally, secrets like this should be stored in an environment variable, so they're not visible when someone, say at the command line, types ps-ax or psax. They can't see the secret when they look at it this way. So we'll store it in an environment variable. But this will get us up and running for now. So now we have to go back to our tokens.go, and let's do something with that JWT bytes variable we created. First of all, we'll check for an error. So let me copy this and paste this. And we're not unauthorized at this point. We're actually going to put error signing. And at some point, again, we're going to want to fix this error JSON so it's not always sending back a bad request header. But we'll do that later on. It's a very simple fix, and this will get us up and running for now. So the last thing to do is to call app.writeJSON and write this JSON file to the user with the token. http:// OK. And we're going to pass it JWT bytes. And we're going to wrap the whole thing in response. Okay. So if this compiles, let's try running it. Go run./cmd/API. Then everything should be all right. Okay, and we have one thing missing here, so let's go get that. Go get it. And let's try running it again. Go run /command/API, and our application is running. So the next step is to go back and modify our front-end code so that we can actually request and receive that token. And we'll get started on that in the next lecture.